Hi, everyone. I'm Nick, and I'm excited to talk to you today about leveraging AI in manufacturing. Today's discussion will focus on using AI to boost efficiency and productivity, and I like to personally really focus on the MVP aspect, the minimum viable product approach to launching impactful AI initiatives. We'll go on a journey from data to digital transformation, talking about AI applications and tangible outcomes. First, a little bit about me. I'm Nick. I'm a CTO. I have extensive experience in AI and ML, robotics, 3D printing, and Industry 4.0 across the startup sector and corporate innovation. I was most recently the CTO of Robotics, now called 1X, where we raised a $30 million round with OpenAI to develop humanoid robots. Previously, I was the head of engineering at Aeon 3D, where we built high performance 3D printers for aerospace and defense and now have 3D printed parts on the space station and the moon. And nowadays, I'm a fractional CTO working with incredible innovators like Ocidia along the digital transformation journey, trying to bring innovation to both startups and corporate innovation. So, according to Deloitte, 87% of manufacturing leaders plan to adopt AI in the next 2 years. And smart production is their top use case, really looking at optimizing and bring efficiency and effectiveness to their operations. But we were all promised this already, weren't we? Wasn't that what Industry 4.0 was supposed to be? Where AI, IoT, connectivity were supposed to bring us all the real time data that we can ever ask for, that we'd ever need to optimize our operations. It was supposed to bring about an entire revolution in the way we do manufacturing. But I personally still see a lot of it missing. I see people doing bits and pieces without fully forming the holistic vision of what they want to do and how and what it means to succeed in Industry 4.0. And there's a lot of talk about digital twins, closed loop systems, and data driven decisions, but many people still need help implementing, running, and architecting these systems in order to set them up for success. And it's sad because it's this connectivity and data flow that's absolutely necessary for successful modern AI applications in manufacturing. And that's where a lot of the problem lies. Per Deloitte, only 18% of companies have seen tangible results, and 91% of companies fail due to not meeting expectations. This gap is partly due to infrastructure limitations, data issues, lack of engineering experience, and just overly complex projects. But most importantly, what I see is that there's a gap in expectation and stakeholder management in how we're doing it and why we're doing it and how it aligns with our mission and vision. And if we want to build a long lasting impact, we need to bring together all stakeholders and build it up piece by piece in a holistic manner that understands your business needs, your operations, your outcomes, and not just what people think you need. And this is where I actually believe that AI and digital transformation is a design problem. It's a user centric problem. It's a user experience problem. It requires us to take the user into focus to bring success. Now, this is one of the reasons why I enjoy working so much with partners like Ocidia. They really take a design centric and user centric approach to the work that they do. And studies have shown that to make these projects a success, it helps to have an expert partner and a baseline digital capability through digital transformation. This leads to way higher adoption rates. It paves the way for better cash flows, better operations, more efficient, more effective overall project implementation. And it's the strategic alignment that's fostered by expert partners that is crucial to bridging the gap and setting companies up for their long term success. So, with all this being said, should you be worried about AI or should you be more worried about your competitor using AI to get the edge? It's really about the ecosystem and the other innovators that are out there pushing their digital transformation agenda. They will be ready for the next generation of manufacturing and the next industrial revolution. And so I bring you all to the key question of the day. Where's your data? Is it visible? Is it observable? Is it accessible? Is it in formats or places or databases where it's easily extracted, transformed, and loaded? Can you take actionable insights or gain business intelligence from your data? Can you bring automation? Or is it still a manual process where people have to scroll through Excel spreadsheets, or even worse, go find paper documentation in a hidden filing cabinet? And all this is just so people can get the data they need to do their job efficiently and effectively. The accessibility of data is essential as it's the first steps to an AI journey. And it's through this digital transformation that we start to set up our systems and our data flows to make these resources available when we need it, how we need it, in order to achieve our day to day goals. And when done well, implementing AI projects with good data access becomes pretty straightforward. So, the worldwide manufacturing sector produces a staggeringly large amount of data, over 1,800 petabytes per year, from sensors to sales orders to operations to production to QC/QA, the whole gist. And it's this proprietary data that is absolutely key to the effectiveness of AI in manufacturing. It's your data, it's your gold. Data is the new oil. It's a moat you're sitting on that sets you apart from your competition. But much of this data is locked away, it's at rest, it's underutilized, it's hidden in a filing cabinet or on pieces of paper. There's often no visibility or accessibility to this data. And that's why we have to undergo digital transformation. It's to set us up for success so that these AI systems can have access to the data in order to generate actionable insights. So let's compare what 1,800 petabytes actually means. This manufacturing data output is equivalent to 385 trillion high quality photos, or 90,000 times the entire Library of Congress if it was digitized, or 3 million times ChatGPT's training data, which many consider to be the absolute state of the art in terms of machine learning and AI. And this is the type of data we're sitting on. This is the type of data that's being underutilized, that's not being transformed into actionable insights to boost our efficiency. So before we jump into implementation details and AI examples, we really need to understand the value proposition of AI in manufacturing. Now, this isn't necessarily a talk about robotics, even though I love robotics and I always try and slip in robots somewhere. But to me, they're honestly the same thing in a lot of ways. Whether it be in the digital space, the virtual space, or the real world, AI and robotics are just intelligent systems that are here to bring automation and efficiency and effectiveness to our tasks. And so we have the 4Ds: dull, dangerous, dirty, and dear. And every application in robotics, AI, and intelligent systems should always trace its value proposition back to at least one of these 4Ds. And if you ever come across an application that you can't trace back to one of these Ds, ask yourself, is it just a fancy application for the sake of being fancy? Is it actually bringing real value? So first up, we have dull. Now, we don't really want to do these tasks because they're boring, because they're tedious, they're monotonous. And this is where AI and robotics really excels. It's these repetitive tasks that we don't want to do that these systems can do much better, much faster, with much higher accuracy and better quality. Humans often get bored, and when we get bored, our quality decreases. We don't want to have to wait for a person who's the bottleneck to get a report if we have automation and AI systems that can auto-generate reports based on the latest and greatest data. In manufacturing, this can apply to everything from inventory management to supply chains to production and data entry. And now we can move people to concentrate on more innovative and creative roles, like improving product quality or customer success. Next, we have dangerous. We want systems to perform these tasks because we want to minimize health and safety risks to humans. We want to take humans and people out of unsafe scenarios, and it's really all about boosting operational safety and efficiency. We want to reduce human involvement in hazardous locations and tasks, and therefore we can ensure consistent quality and worker protection all in one go. In manufacturing, a great example might simply be PPE compliance and using computer vision to make sure that everyone's wearing their hard hats. Next, we have dirty tasks. This is where we want to try and reduce human contact with contaminants, with filth, with things that we don't want to be around because of an icky factor. This is often paired with dangerous for workplace safety. And by boosting efficiency and effectiveness with these systems that can manage these hazardous and filthy scenarios, we can ensure consistent outcomes. We're essentially taking people out of the environments and places that they don't want to be and are not the most effective, where a system can be more effective. Finally, we have deer. And these are situations that have a very high cost or quality requirement. Predictive maintenance is a great example in manufacturing where we essentially want to maximize uptime and minimize downtime of our machinery. A lot of people don't consider the cost of downtime until it's too late. And using tools like predictive maintenance, we can better manage the life cycle of our equipment. It leads to better resource management, better human resource management, better financial resource management, and just overall improved operations. So let's get into the fun now with some examples. First up is a little computer vision, smart production, health and safety, and quality inspections. It's one of my favorite areas of AI in manufacturing. And so studies by Deloitte and McKinsey have shown that using AI manufacturing for smart production for quality inspection can lead up to 50% increases in productivity and operational efficiency. We can use machine learning and visual inspection tools to measure our quality in real time, which really allows us to capture defects earlier in the process when rework or corrective actions might be cheaper than at the final QA step right before you're about to ship, which might cause delays and unhappy customers. This allows us to capture root cause analysis in situ and bring that knowledge back to our engineers and our team to drive continuous improvement across our whole organization as part of a continuous culture. We can also keep an eye on our workers, making sure everyone wears their PPE, their hard hats, their masks, and helmets. And this really is a way of making sure that our whole operation from end to end is running as intended, from production to worker safety to our quality. So, if you want to build a computer vision project in manufacturing, it's essentially three simple steps. First, we're going to collect some data and we're going to annotate it. This can be as simple as taking photos of all your parts and assemblies across a production line. The next step will involve the model development, the training. We're going to take that data, we're going to plug it into an off-the-shelf AI model that's pre-trained on existing data sets, and we're essentially going to fine-tune these models to better fit our data. Now, for me, off-the-shelf models are a commodity infrastructure in today's AI world. We don't need to reinvent the wheel by building models from scratch. We're going to take things and infrastructure that already exists and adapt it to our needs. By leveraging this existing infrastructure and fine-tuning it to our needs, we get to go to market faster, we get to have faster value, we get to have feedback faster, we can deploy faster, and we can move on to the next step faster. And this last step here is the deployment step, where we deploy our models to the shop floor, get the feedback from our users, from the production team. We can test our assumptions, validate some open questions, and continuously improve and learn new things and iterate. And it loops back. We'll collect more data. We'll refine the model some more and deploy again. And it's a continuous cycle of continuous improvement. It's really going to become part of your culture once you get into it. And honestly, all AI initiatives follow essentially these steps. So one fun example of smart production comes from Sugar Creek Brewing, where they looked at using AI and IoT to perfect their brews. They were having issues with spillage and lost product during the brewing process, and by collecting parameters like pH, the fill time, the temperature, the pressures with different sensors, they fed this all back to their cloud data lake for analysis. They identified inefficiencies in their bottling process, and resulted in over $10,000 a month in savings by fixing just a few simple things like foaming and fill level issues. And this let them reinvest their savings into further production expansion, experimenting with new recipes, market expansion, and really bringing about further innovation and R&D. Another example comes from the NIM group, who want to use AI to reduce scrap rates and costs in steel manufacturing. And with sensors and monitoring and analytics, this led them to figure out the optimal machine settings that allowed them to reduce these scrap rates and noticeably drove down their cost and boosted their production consistency and capacity. It allowed them to essentially optimize their inventory management end to end. And my favorite part of this story is, unbeknownst to them, now less experienced operators can be onboarded and ramped up much more quickly instead of having to depend on only senior expertise to get the job done. So there is a whole human resources component to this innovation and initiative as well. This lets them generate more steel that they can sell rather than be sent to a scrapyard. Per McKinsey, AI's greatest value in manufacturing is actually in predictive maintenance. Some studies estimate that it'll bring upwards of $700 billion in cost reduction over the next decade. And predictive maintenance is really just looking at data analytics to identify equipment malfunctions preemptively. We're trying to be proactive with maintenance instead of reactive. And we have to ask ourselves, why are some maintenance cycles static? Why do we do maintenance every 2 weeks, every 6 months, every year? Why isn't it more dynamic? Why isn't it based on usage patterns? And to be honest, Murphy's Law, a machine will always end up breaking when you need it most. So, how can we better plan around the machine's life cycle? So, given some operational constraints and our usage patterns and analytics, we can build AI models around optimizing a machine's lifespan, around the maintenance cycles, so we can proactively optimize and plan for maintenance instead of being hit with it reactively. And this is really all about optimizing our operations, increasing our productivity, and really minimize operational costs. One implementation example in predictive maintenance comes from OYX Cement, who launched an AI initiative to collect data from their diverse and international plants. It allowed them to predict and prevent mechanical failures and bring systems back up and running in a quarter of the time that it traditionally required. What I really like about this story is that they took it a step further and they empowered all their staff with data tools. So it wasn't only the data scientists and machine learning engineers, but all the engineers, technicians, and maintenance team became their own citizen data scientists, empowered to collect the data they needed in order to bring about results. This democratization of the data process enabled more informed decision making across all levels of the organization and enhanced, the overall efficiency and the quality of their operations, leading to increased efficiency, cost savings, and even better, CO2 emissions were reduced. Very similar to our computer vision example, from an implementation standpoint, it follows a very similar path that all AI projects tend to do. We start with some sensors, we collect the data, we feed that data into a data lake where we have access to it for AI training, model building, inference, analytics. We then have data driven decisions and actionable insights that can be derived from the model and the data. And this all forms a continuous part of our data driven culture, our AI driven culture. And just think about how much historical data that you may be sitting on right now on all your machines, whether it be CNC machines, molding machines, whatnot. We have their maintenance records, we have their run times, we have their error logs. They're all just sitting there. It's ripe for capture, it's ripe for a better understanding of your operations. From a business development and sales standpoint, we can also look forward in time and do demand forecasting. What starts as simple Excel time series models can be further improved with AI systems. We can look at trends, cyclic behavior between different types of data sequences and input variables, both internal and external. And this goes beyond what humans are capable of seeing in the data, what we're capable of modeling with just Excel spreadsheets. This will become part of our daily operations instead of a once off, once weekly, once quarterly, once monthly effort that goes stale the minute you export the spreadsheet. By definition, the minute you hit save as or export to PDF, that data is stale. And so ask yourselves, do your current spreadsheets and models include external data sources, weather, fuel prices, market and competitor trends? Are you pulling all this data together to make a cohesive, holistic view of your overall operations? And there's so much freely available external data that people don't leverage. And when combined with your internal proprietary data, it only makes it so much more powerful. And once again, the process of implementing this sort of project is simple and follows the same steps for all other projects. There will always be data collection and pre-processing, where we take the unstructured data from Excel spreadsheets and ERPs and sales orders and feed that into some form of database, like a data lake. We'll perform some simple pattern recognition and analysis. We'll build models and refine them. And then we'll integrate external variables that may have an effect on our overall operation or an impact on our clients and market forces. And we'll iterate. And what starts off as often a simple go, no go type model becomes more and more accurate and makes more and more precise decisions. One of my favorite examples of this comes from Walmart. Nearly a decade ago, they published a recruitment competition challenge in sales forecasting. Given the sales record across 45 stores and some fuel prices, the holidays, weather pattern data, regional variability, and other basic data points, they wanted candidates to predict the upcoming sales numbers for these stores and departments. Guess what? It ended up being very accurate. And it's a lesson that combines already accessible data from ERP systems, sales numbers are easily accessible, with external data factors like weather and holidays and seasonal influences. And it's this combination of the two that leads to much more powerful outcomes. It's the combination of internal and external data and all this freely available data that's just not being used. But when combined and when utilized, leads to really innovative outcomes. So, following the pandemic, everyone now knows about supply chain, logistics, and procurement, and the world's challenges around this. And just like demand forecasting, predictive maintenance, and smart production, we can use data driven systems to predict things like late shipments across our supply chain. We can ensure that we reduce stockouts and better manage our on hand inventory, whether you want to do lean manufacturing or not. We can leverage these machine learning techniques to understand our demand and plan for incoming inventory much better so that we don't end up with too little or too much inventory. Really trying to have our whole system be dynamic and agile instead of static and reactive. This lets us better adapt to dynamic market trends and forces. And if you think about it, the world doesn't really update on a monthly or quarterly basis. Everything's in real time. So why is it that often our logistics are only updated quarterly or monthly or whatnot? Are your systems and operations reacting in real time? Can we be proactive in real time? That's the real goal. And so, through many studies from Deloitte, McKinsey, Gartner, been shown that manufacturers that adopt these AI technologies for supply chain logistics bring about 5% increases in inventory availability and are able to decrease waste by upwards of 8%. In one case study, Japan Tobacco International, the makers of Camel cigarettes, initiated an AI project for supply chain logistics, and they included external data sources such as weather and holidays to improve their logistics planning and truckload optimization. This is very similar to the Walmart example that we saw previously. Freely available external data, simple data, weather pattern and holidays, very easy to access. And the modeling resulted in a 15% reduction in unnecessary unloads and a 25% decrease in carton movements. We have less people moving around, we have less need for trucks on the road, we have a more optimal end to end system. Even things like worker health and safety And worker injuries can be reduced by having decreased movements and unloading and boxes moving around our facilities. And all of this leverages, once again, some proprietary internal data that's just not being utilized and some freely available external data that increases the overall power when combining these two data sources to boost our efficiency and our overall outcomes. We can even go a step further and forget about ourselves, our inventory systems, our machinery, and think about the customer. How can we set them up for success at the same time as ourselves, of course, by using predictive and dynamic pricing? We can leverage real time demand, our operational efficiencies, and other influencing factors to determine what the pricing should be, not what we guesstimated it should be. We can make informed decision making across all our teams such that our pricing strategy isn't just determined by one sales department on a yearly basis, let's say. Our pricing decisions can be based on a holistic view of our entire organization and our operations, end to end, from raw materials to procurement to the cost of labor and the yield rate. All of this can be dynamically determined. We can beat our competition if we can better model our pricing strategy based on real-time dynamic data and business intelligence instead of these guesstimates that are traditionally seen in a lot of sectors, or stale decisions or stale data from past quarters, past years. We can be agile with our pricing strategies. We can adjust to market shifts. We can adjust to resource availability and other factors that sets our customers up for success, getting them the best price that meets their demand, and sets us up for success so that we can determine the best price due to our internal factors. So that's all fun and great, but how do we go about getting started? So back to the gap that I discussed at the beginning of this presentation. There's a gap between expectations and stakeholders and capabilities and the outcomes that we want to achieve. And study after study have shown that it's the partnerships with leaders in digital transformation, AI, and data that bridge the gap to these capabilities. The most successful companies that have achieved tangible results have constantly cited that as their partners' strategic and technical consulting, that was the top attribute that led to the success of their project's implementation. And even better, these same studies predict that companies that are on track to implementing their AI initiatives can double their cash flow in the next decade. So we haven't even got started on what's coming next. We're still stuck on Industry 4.0, and there's lots of people still targeting Industry 4.0 as their long-term goal and mission and vision. But innovative leaders are already talking about Industry 5.0, where we have human system collaboration. What starts with data flows and AI systems soon turns into moving towards a world with AI human collaboration running the operations together equally. Business units, both virtual and real, are working together where the barriers and silos between departments start to crumble. And the whole organization will run as an end-to-end system. So I ask you once again, after everything we've seen here today, where's your data? If it's available, how can we leverage it to give you the edge to stay ahead of the competition, to improve your efficiency, and really redefine the next generation of your business? If it's not available, what are you doing about it? Who are you working with to set your strategic roadmap and bring digital transformation to your operations to set yourself up for success and a solid foundation for the future of AI and an AI-driven world? Thank you very much, and I hope to be hearing from you soon.